Hi guys, this is Shivadi. Welcome to the DevOps interview question and answers. The first question is, what is DevOps and its advantages? So DevOps is a software engineering culture and practice that aims at uniforming the software development and software operations. The main characteristics of DevOps movement is strongly advocate automation and the monitoring at all the steps of software construction, from integration, testing, releasing to the deployment in infrastructure management. So the DevOps is a set of practices intended to reduce the time between committing a change to a system and the change being placed into a normal production while ensuring the high quality. If you go with the traditional waterfall model or the agile model, where we are going to see that development team is a separate, QA team is separate, and operations team is separate. So once the development team develops, then it is going to be to the QA, and QA do the testing, and if there is any issues are there, again it is going to for the development for the fixing those issues, and then finally it is comes to the operation. So each deliverable, when moving from the one team to the another team, that is where actually most of the time is going to be consumed. That is the reason, in order to implement the DevOps, there is a organization culture has to be changed in such a way that as a one team, it should contain both the development, QA, and the operations. The end goal of it is we have to deliver this software as quickly as possible with the highest quality, because now time is nothing but the business. So that is the reason DevOps is going to help you to implement the change as quickly as possible by ensuring high quality. Now, if you come with the DevOps culture, so DevOps culture is basically, first we need to plan for it, and then we are going to code it. Then once coding is happening, then testing will perform. Once testing is done, we are going to build the software, that is packaging we are going to do. That means artifacts we are going to, then we will release. And configuration is basically deployment. We are going to take the help of certain tools, and which will basically do the configuration management. And finally, we are going to monitor. And if there is any issues during this monitoring phase, again we are going to plan it, and then code it, then testing it, and packaging, releasing, configuration management we are going to do help of certain tools, and monitor. So this is a continuous life cycle of the development process. So this is called as a continuous improvement and continuous delivery. Okay, so by using the DevOps, the following are the advantages: improved deployment frequency, because we can deliver the software every day or even couple of hours also. And also faster time to the market, that is nothing but getting the requirement and delivering to the customer is very fast. And a lower failure rate for the new releases, because we are actually, if this is everything is going to be monitored once you are placing the code. At the moment we are going to take the monitoring, with the monitoring, and monitoring will give us the analysis what are the issues, and immediately we can fix those problems. And shorten lead time between the fixes. So because we know once we deploy the changes to the production, immediately we will come to know how the system is going to behave. Finally, faster mean time to recover, because if, for example, whatever the new release you are giving to the production, if failure happens, by using this configuration management tools, we can immediately revert the old version of the application. So these are the advantages if you go with the DevOps culture. Next one is, what are the tools used in DevOps? As if we do with the manual monitoring or the manual deployment systems, it is going to be a time consuming process and error prone. That is the reason we are going to use couple of tools to automate all this process. So let us look at the what are the tools. For the coding, basically we use the source control management tools like a Git, SVN, and basically we are going to host, or we are going to commit all the code changes to either a Git repository or the SVN, and then we are going to use the build tools like Ant, Maven, Gradle, and testing tools. In order to do the unit testing and the integration testing, we use the tools like a JUnit and Selenium. And in order to the continuous integration tools like a Jenkins and Bamboo, these are the continuous integration tools. which actually takes the code from the SVN, that is a Git or the SVN, and it will build the software, and it will trigger the JUnit test cases and the integration test cases and see whether the all the unit test cases are executing properly or not. And also for the monitoring tools, we are going to use the Nagosh or Splunk, Sensio and New Relic. These are the monitoring tools we use to monitor the performance of the application and the usage of the application. And also we are going to use the configuration management, that means continuous configuration automation tools like Puppet, SaltStack, Ansible and Chef. So basically these are the tools which actually help you to deploy your software automatically on our cluster, or the it is like a child master and slave, or the client as server model. And finally, we are going to use for the reporting purpose, we are going to use the Elasticsearch, Logstash, and Kibana. These are going to help you to provide the search criteria based on the text search. You can monitor or the analysis, the logs or the monitoring you can perform using the Elastic stack. Now, if you see in the pictorial representation, so first basically in the planning, we are going to take the help from the Jira, and also Git and SVN is basically for the code base to commit. And we have the build tools like Ant, Gradle and Maven. And for the testing, we use the Selenium and the JUnit. And for the integration, again, for the deployment, we use the Puppet, Chef, and SaltStack, Ansible. So these are the deployment tools. And for the operation and the monitoring basically we use the Nagios or the Senso or Senso. These are the tools we use for the monitoring. And in order to do like a automation, basically DevOps is basically focus on the automation and integration. In order to do that, what is the scripting language used for the DevOps? The most frequently used scripting language is the Python, or if you are familiar with, you can use with the Ruby, and also Groovy it is also going to support, or you can go with the shell scripting. So these are the scripting language generally used, but most popular scripting language which help you to develop the software faster is the Python. And the next question is, what is meant by infrastructure as a code in DevOps? For example, if you go with the traditional way how you are going to configure the servers, then there is a lot of manual effort. For example, you want to create a new software, a new server, then there is a lot of human effort is going to be involved to create a new server. That is the reason DevOps always comes with a culture called as a infrastructure as a code, so that instead of doing the manual the administration go and create a instances or the servers manually, instead of that what we are going to do is we are going to provide a scripts which actually does this job. So based on the script what we are going to return, and also based on the configuration what we are going to maintain, automatically the script will be executed, which will be actually monitoring our application, and dynamically it will create and shut down few of the servers. So infrastructure as a code is a process of managing and provisioning the computer data centers to the mission readable definition files. Those are nothing but the scripts rather than the physical hardware configuration or the interactive configuration tools. So the definitions may be in the version control system. So once we provided the scripts, what we are going to do is these scripts are actually available as part of our source control management tools like a Git or the SVN, so that these scripts will be executed by the our configuration management tools. So the advantages of the infrastructure as a infrastructure as a code are: first one is cost reduction, and the second one is faster execution, third one is the risk mitigation. So the cost reduction is aims at the helping not only the enterprise financially, but also in the terms of people and effort, meaning that they can removing the manual component, and people are able to focus on their efforts in another enterprise task. And the infrastructure automation or the faster execution is basically speed the faster execution when configuring your infrastructure and aims at providing the visible to help other teams across the enterprise work quickly and more efficiently. And third one is risk mitigation. Risk is associated with the human error like a manual misconfiguration. Removing this can be decrease downtime and increase reliability. So risk mitigation is always there whenever you are applying like a developer are going to configure, then there is a misconfiguration might happen. But as the properly, if you are script, you write a script which actually do that job, and then we can avoid the human errors. And the and IOC again, there are three approaches for the infrastructure as a code. The first one is the declarative. Declarative is basically focus on what. So this approach focus on what the eventual target configuration should be, and then it defines the desired state and the system execute what needs to happen to achieve that desired state. So declarative approach is basically defines what you have to do, and imperative is basically tells how. So this approach focuses on how the infrastructure is to be changed to meet this. So this defines the specific commands that needs to be executed in the appropriate order to end with the desired conclusion. And third one is intel intelligent. It is basically focus on why. So intelligent approach focus on why the configuration should be in a certain way in considering all the co-relationship and codependencies of the multiple application running on the same infrastructure. So it determines the correct desired state before the system execute what needs to be happen to achieve a desired state that does not impact codependent applications. So these are the three ways basically, three approaches basically to do infrastructure as a code. Now, infrastructure as a code has two methods. One is pull based, another one is the push based. In the case of pull based approach or the pull method, what is going to happen? The server to be configured will pull its configuration from the central controlling server. So it is like a central server, you will have the all the configuration. Now the nodes or the child, whichever it is going to pull the central server and it will pull those configurations. Second one is push. So push method, what is going to happen is controlling server push the configuration to the desired system. That means master will have all the configuration related changes. Now the master will be push these change configuration change to the childs. So these are the two methods how IOC can be used. And the third next question is what are the tools used for continuous configuration automation? So continuous configuration automation is basically tools can be thought as a extension of traditional infrastructure as a code frameworks. It leverages infrastructure as a code to change, configure, and automate the infrastructure, but also provides the visibility, efficiency, and flexibility in how your infrastructure is managed. These additional attributes provide the enterprise level security and compliance, making companies keen on implementing these type of tools. For example, if you use the Ansible, it is actually basically released by the Red Hat, and it works IOC based on the push method and approaches declarative and imperative. Basically, this is written in Python. Similarly, Chef, it is released by Chef, and the IOC method is pull based, and the approach is imperative written in Ruby. Similarly, for the Puppet, released by Puppet, it is basically pull method and approach is declarative written in Ruby. And Salt Stack, it support both the push and pull methods, declarative and imperative written in Python. And finally, we have the Terraform. This is HashiCorp. It is released by, and it is push based and declarative approach and written in Go. And the next question is, what is the difference between Agile and the DevOps? So Agile is basically an iterative approach which focus on collaboration, customer feedback, and small rapid releases. In the case of DevOps, DevOps is a set of practices intended to reduce the time between the committing a change to a system and change being placed into a normal production while ensuring high quality. The purpose is Agile help you to manage the complex projects, and also it will help you to reduce the time cycle between the each change request. You can deliver within a 2 weeks or 3 weeks based on the sprint plan. You can do, but DevOps central concept is to manage the end-to-end engineering process and delivering the change requests as soon as possible by ensuring the high quality. The task is agile process focus on constant changes. That means when you go with the agile model, you are ready to accept the change, but DevOps is focused on the constant testing and delivery to make sure that our software release happens as quickly as possible. Implementation: Agile method can be implemented with a range of tactical frameworks like a Sprint, Safe, and Scrum. But the primary goal of DevOps is to focus on the collaboration, so it does not have any common accepted framework. Duration: Agile development is managed in the units of sprints. The time is much less than a month for each sprint. But DevOps strive for the deadlines and benchmarks with the major releases. The ideal goal of the deliver code to production daily or even in few hours as well. And the feedback is basically tested with the UAT. In the case of Agile, feedback is basically provided by the customer once you deliver that a part of the sprint. But here, feedback comes from the internal team and monitoring tools. Once you deliver to, in the case of DevOps, once you have released it to the customer in the production, then automatically based on the monitoring tools, you'll come to know the feedback how that particular software is working. And targeted areas, software development, it is for the end-to-end delivery by focus on the automating most of the software development life cycle. And automation, Agile does not emphasize on the automation, though it helps. But automation is the primary goal of the DevOps. That is the reason by using those help of the monitoring tools and the DevOps tools, we are going to improve the complete end-to-end life cycle of a particular change request. Goal, it addresses the gap between the customer needs and the development and testing teams. Here, they address the gap between the development and testing and operations. Quality, Agile produce better applications suited with the desired requirement. It can easily adapt according to the changes made on the time during the project life. So DevOps along with the automation early removal contributes to creating better quality. Developers need to follow the coding and architectural best practice to maintain the quality standards. So tools are used in the case of Agile. Jira, Bugzilla, or Kanban are the some of the popular Agile tools. In the case of DevOps, we are going to use the Puppet, Chef, SaltStack, Ansible, Git, Jenkins, and then Python, Ant, Maven, Gradle, Nagosh, Splunk, Sensu, Neuralink, JUnit, Selenium, AWS are the popular DevOps tool. So these are the some of the core concepts related interview questions. In the next session, I am going to cover more on related to the DevOps tools. Thanks for watching. Have a nice day.